playing music earlier, but okay. Lucas, I have your attention, please. I have everyone's attention. Excellent. Would you like to answer his question quickly, Mike, so he can proceed? Answer his question. You can do it. I'm not annoyed. I'm just serious.
It was a statement.
It was a statement. Excellent. Excellent. No response. Statement without response. Excellent. Excellent. Now, this is on buoyant forces. Now, this is period 8. This is classroom lecture fluids 5. This is the problem that we're going to do. Are you ready? Okay. When something's floating, a battleship, a boat, a piece of wood, these are the dynamics involved. The buoyant force equals the weight of the ship. The buoyant force equals the weight of the wood. So this is the weight, correct? We call that FW. And that's the buoyant force. Buoyant force is an upward force. If I'm in a pool and I take a ball to the bottom of the pool, what's going to happen to the ball? It's going to go up. Because the buoyant force is greater than its weight at the bottom of the pool. Correct? At the bottom of the pool. Because the entire ball is displacing the water. So the buoyant force is a lot. Understood? Right. But if the ball is floating, only a portion of the ball is immersed, isn't it? Why? Because, this is the rule. Are you ready? How do I know what the buoyant force is? The buoyant force equals the weight of the volume of fluid displaced. Clear? So, if I have a piece of wood and it's floating on the water and it displaces a liter, I find the weight of that liter, and that's the buoyant force. Right?
Yep.
This is the rule, though. This is the second part. You ready?
Yes.
When something is floating, the buoyant force and the weight are equal. That's the physics. Clear? So how can I determine the weight of a battleship? How can I determine the weight of an aircraft carrier? I can find out how much water it displaces, and I find the weight of that water, and that's the weight of the battleship. You ever hear, like, it's a 40-ton ship? You ever hear those words before? Yeah. You know, the Germans sunk 2 million tons of ships during World War II. Well, what that means is, thank you, Michael. That was secretly driving me crazy. I didn't even realize what it was. I appreciate that. Well done. Extra credit. Appreciate it. I thought I was losing my mind. So what that means is this, that if the ship is a 40-ton ship, that means the weight of the volume of water it displaces is equal to the weight of the ship. You understand that?
Yes.
Now, if I have a 2 cubic meter balloon, 2 cubic meter balloon, like a Goodyear blimp, a big balloon, not as big as a Goodyear blimp, but a balloon, a balloon blimp. But I know the balloon is floating, correct? So if the balloon is floating, its buoyant force equals its weight, correct? Yeah. Now, so if I can determine its buoyant force, I know its weight, correct? Well, the equation for buoyant force is FB equals the density of the displaced fluid, air, times G times V, the volume of fluid displaced. Density of fluid, volume of fluid. What's the volume of fluid that's displaced? 2 cubic meters. What's the density of air at normal temperature and pressure? NTP, 1.2 kilograms per cubic meter. Okay? So what is the FB? What is the FB for the balloon? Can you do this in your head? 1.2. I'll leave off the unit labels because we are unit label clean. Meters, kilograms. Understood?
Yeah.
Times 10 times 2. What's that equal?
24 meters.
FB equals 24 newtons. So that's the weight of the balloon. Now, we're not taking into account the actual material of the balloon. We're just ignoring that for a minute. Is that okay? But isn't that the total buoyant force? So isn't that the total force the balloon can carry is 24 newtons? Not bad. About 5 pounds. Okay? Right? So the buoyant force of the balloon equals, what did I say? 24 newtons? Is that right? Correct? Now, what's the weight? Isn't it carrying helium? Right? Helium is in the balloon. So it's carrying helium. So how much additional weight can it carry? So don't we have to subtract off the helium? Don't we have to subtract off the helium?
Yes.
Well, isn't the helium floating? Yeah, it's floating with the balloon. So if we determine the buoyant force of the helium and subtract that from the buoyant force of the balloon, won't that equal the additional weight that balloon can carry? Let's do it. So it's going to be 0.166 times 10 times 2. Is that right? Is that right?
Yeah.
Now, for argument's sake, just to make it a little bit easier on the eyes, let's round 0.166 to 0.2. Is that okay?
Yep.
All right. So that's going to be 0.2 times 10 times 2. So the buoyant force of the helium is going to be what? It's going to be 4 newtons. So far, so good. We're almost done. Okay? And then we're going to celebrate. Oh, sorry. Too loud, Katie. Sorry. Turn that microphone down. Okay? So the buoyant force of the helium equals 4 newtons. So what is the additional weight the balloon can carry?
28.
What's the load? Michael?
28.
What is it?
20.
20 newtons, right? Understood?
Yep.
Get it?
Yep.
We're done.